Thank you so much, Mary, for the introduction. Hey, everyone. I'm Aditya Bansal, and I'm not a wizard, although I'd like to be one. I'm a founding engineer at Cortex, and we're building an internal developer portal to help engineering organizations gain visibility into their microservices by cataloging all your data. Today, I'd like to begin the talk by asking everybody in the room two big questions. Who here has worked on a project that took much longer than they originally thought it would? OK, virtually everyone. How about people who worked on a project for weeks or months, only to realize that the expected outcome of the project is very different from the current direction, and they either had to scrap the project or at the very least change scope dramatically? I thought so, because honestly, me too, for both of the questions. Much like most hands in the room, my experience is very, very similar. And if you would entertain me, I'd like to just take a minute in front of everyone to reminisce over my early days as an engineer and share why I became passionate about this topic. So, story time. It was the year 2017, and I had just graduated out of college. And as a gleamy-eyed engineer in Silicon Valley, I decided to join this super early stage startup called X. It's not actually called X, I'm just calling them X. And this was super early stage. I must have been engineer number 15, and you know what that means, right? Move fast and break things. And break things we did. At this company, we would not design anything, we would not write down anything. There would be no tech specs, no ADRs, no getting buy-in from senior or staff plus engineers. We would just jump gung-ho into implementation on day 0 of the project, no matter how complex it might be. Then, as most people do, I moved on to a second company. Let's call it Y. This was also an early stage startup, and I thought it would be very similar to my previous one, but on the contrary, it was very, very different. At this company, we would design for weeks, ranging all the way till months. We would try to answer every single question, iron out all the details before writing the first line of code to production. So, why am I sharing any of this? Is it to malign any of my previous teams? Absolutely not. It is just the nature of an early stage startup to be focused on delivering product and not engineering design philosophies. It is just to emphasize that even amongst small, early stage startups, the industry hasn't agreed upon how to start a technical project. So if I think about the industry at large, I feel like we're divided into two very extreme camps. On the one hand, what I usually call the YOLO school of thought is this idea that you don't design anything, you start writing code and you figure things out along the way. It's kind of like my first company, X. And these teams usually run into the whoops, we totally forgot about that problem midway through the project. And on the other, more commonly known as the big design upfront school of thought, is this idea that you iron out every single detail before writing the first line of code to avoid any surprises down the line. But as most hands in the room showed, I think we all agree that these extremes don't exactly work. So, what do we do? Here is where I got introduced to the concept of a technical spike by my first mentor. A spike lives somewhere in the middle of the two extremes and helps iron out the most important details of a project. And that's the key. It helps you focus by removing all the other distractions so you can finish just enough design or answer just enough questions. A spike, when done correctly at least, is supposed to do two things extremely well. Number one, it's supposed to help you form a full understanding of the product you're trying to build, or rather, the problem you're trying to solve from the end customer's perspective. And the customer could be anyone. It could be the customer that your company is selling to, or many times for internal teams like developer tooling or platform and infrastructure, your customers are your fellow colleagues, other engineers, or other teammates. Second, it's supposed to help you form a full understanding of the technical landscape of the project. These could be the known unknowns or elements that you know from day 0 that you absolutely need. For example, if you're adding a new e-commerce platform and you don't already have a cart-like functionality in place, it's safe to imagine that you'd need a new API or a microservice or whatever your architecture is to operate on it as if it's a cart. But then come the unknown unknowns, the trickiest part of the project. What are the side effects this project could have? What are the different teams you need to work with? What are the assumptions that have been made along the way that we now need to go back and challenge? This is where I spend a majority of my time on a new spike in, and I'd share my lessons here in just a second. But before talking about how I usually go about spiking a new project, I love to share a few sure-shot ways of ensuring that a spike goes horribly wrong in the hopes that it saves some of the people in the room the same pain that I've had to go through many a times. Number one, writing production-ready code. One of the biggest time sinks during a spike is writing clean code, getting code reviews, writing test cases. Assume that the code you're writing is throwaway code and is not going to get merged anywhere. Number two, solving for everything. The purpose of a spike cannot be to limit the number of unknowns to 0. It is just to reduce their occurrences by a little bit to improve your chances of success. And finally, taking all the time in the world for the spike itself. Spikes are supposed to be a starting point to the projects, not the project themselves. So time box your spikes to maybe a week or 2 weeks, depending on the complexity, but focus on getting things to work. Okay, now if you're somehow convinced and are ready to join me in this camp of a middle ground between no design and upfront design, I'd love to share how I usually go about spiking a new project. First, I create a new branch called Project-Playground. As you can see, at my current company, I started doing this several years ago. And at the beginning, even I thought that this branch should be passing tests and clean code and everything, hence the first green check at the very bottom. Then I grew as an engineer, and I realized that I could just let the CI run. It's okay. It's not going to get merged anyway. So hence the next few red checks. And then my team also grew, and they disabled tests on my branches, thereby saving a sizable chunk of our seed fund. Thankfully, the finance team was completely unaware of all of this, and I'm just going to have to figure out how to hide this presentation from them. But jokes aside, this branch truly is a playground, and I treat it as such. So I start off by listing all the new greenfield changes that I need. These are the interfaces, the classes, the modules, database changes, schema, front-end work, everything that I can imagine. Keeping things fairly high level, only focusing on how the different pieces communicate with each other, not fleshing out any of the details just yet. This is also the time I spend with my customers to solidify my understanding of the problem that I'm trying to solve. But then come the unknown unknowns, the trickiest part of the project. In this phase, the biggest question I'm trying to answer is, what could go wrong? What will break if I merge this code to production right now? What are the ripple effects of this project? So I start off by exploring all the different code paths that I'd be taking, tagging any area of concern that I find. I create these annotations in a language like Java or Kotlin. They're very easily accessible. I give them different categories, and I leave them through all my explorations. If your language doesn't support annotations, code comments also work, though. Once I've explored enough of the code base, it's time to write everything down. So I start off by creating a new tech spec-like document, although it's fairly minimalistic. And I dump down, number one, what's new? What am I adding to the code base? Number two, what's being modified, and the different teams that I need to work with or get buy-in from. And number three, most importantly, what do we need to discuss? What did I find during the process of a spike that warrants a technical discussion with the rest of the team? You remember the annotations we created in the previous slide? This is where they come in handy, because I can just grep for them and find what is missing. And one final caveat I'd love to share with everybody is I shared the process of a very specific kind of a spike today, which is a new project on an already existing code base. But there are various different kinds of spikes. So put everything I spoke about today in your context, because that is what will make the biggest difference. Lastly, I like to leave you with this quote. Those who have knowledge don't predict, and those who predict don't have knowledge. I hope the process of a spike I shared today helps people in the room build a better knowledge graph of their projects going forward. Thank you so much. That's my time.